Hello, everyone, and welcome to another episode of Echo Live. My name is Paulette, and I'm the staff astronomer here at the Michigan Science Center. I have a super cool job. So here at the Michigan Science Center, I run our planetarium, but I also am a volunteer for NASA. So my day job is here at the Michigan Science Center as our staff astronomer and planetarium director, but I also volunteer for NASA as something called a solar system ambassador. This Friday, the Michigan Science Center is having a wonderful program called Scopes in the City. Our Scopes in the City event happens rain or shine on Friday from 8 p.m. to 10 p.m. And we'll be taking a look at some of the objects we can see up in the nighttime sky. Now, if it's cloudy or if it's raining, we'll probably move that inside and take a look through some telescopes at some objects that are inside the Michigan Science Center. But we'll still be able to use a telescope. We're very, very excited about that. Telescopes. Today, we're going to talk a little bit about what telescopes are, how telescopes work, and some of the famous telescopes that we have. So, telescopes come in two different types. We have a refracting telescope. One more time, refracting telescope, and a reflecting telescope. One more time, that's reflecting telescope. So refracting and reflecting telescopes. Those telescopes work in two different ways. A refracting telescope takes light and refracts it through lenses. So here we can see the light coming from this distant object coming into the telescope. And we have a large lens right here that bends the light. It'll bend or refract the light through the lens to focus the light here. And there's a small lens down here at the bottom that'll actually allow this focus to focus on your eye. So refracting telescopes bend the light through lenses, but reflecting telescopes are exactly what you might expect. They contain mirrors instead. So with a reflecting telescope, the light comes in and bounces off of this primary reflecting mirror here, back up to a smaller mirror. And then there's a lens right here at the eyepiece that allows you to see the object and actually focuses the light on your eyeball. So reflecting telescopes still do use lenses, but they mainly use mirrors. Now, there are pros and cons to refracting and reflecting telescopes. One of the cons to a refracting telescope is that it can't get very big. If it gets too big and the lens starts to get too big, then it's going to make everything look a little bit funny that you're looking at. So to get larger and larger telescopes, they actually tend to use reflecting telescopes. There is a huge refracting telescope actually in Wisconsin, not too far away from where we are here in Michigan. But that refracting telescope called the Yerkes Observatory is actually just opening back up. So that's sort of the typical telescope that we might think of. The reflecting telescopes are all over the place, and it's sort of a newer technology when it comes to telescopes. The first telescope that Galileo Galilei first put to the sky was a refracting telescope, but our modern telescopes are are much more likely to be a reflecting telescope, especially considering their size. Speaking of size, here we have all sorts of different types of mirrors. So the largest of these mirrors you can see right here is actually larger than a basketball court. And some of our smaller ones that we have here are, they're not huge, but they're also not tiny. So here we have the Yerkes Observatory that I was telling you about. That's typically as large as we can get with a refracting telescope. With a reflecting telescope, we can get much, much bigger. But you might notice as we get larger, the mirrors start to become segmented instead of solid. Part of the reason that we've started segmenting our mirrors, like you can see down here with the James Webb Space Telescope and some of these larger telescopes here, the reason we have started to segment them is because we're looking through our atmosphere. Our atmosphere can actually make light move and refract around. So to be able to see things a little bit clearer, we have started to use segmented mirrors so that we can actually change the shape of the mirror and get a better view of the object that we're trying to see. So two really famous telescopes that we can definitely see on here. Right here, we have the Hubble Space Telescope, the James Webb Space Telescope, and we'll talk about that one a little bit more a little later on. The Twin Keck telescopes, those are in Hawaii. And lots of different types of telescopes. When I was at Kitt Peak National Observatory, I used a 0.9 meter telescope, so very small compared to some of these huge telescopes that are out there. And I also got to take a look at the 4-meter telescope, which was really, really cool. So telescopes have a variation of different types, different sizes. And here we have some of our telescopes that we use pretty regularly. So for example, down here, we have the Keck telescope, Keck twin telescopes. Like I said, these are on Mauna Kea in Hawaii. And these two telescopes right here work together to get a better view of the objects. We can use telescopes that are in our upper atmosphere, like this one right here called Sophia, which is actually flown in an airplane. And we also have some of our telescopes in the in low Earth orbit, like the Hubble Space Telescope, the Chandra Space Telescope, the Fermi Space Telescope. You can see that all of these different telescopes are looking at the world in different wavelengths of light. So we think about telescopes looking here in the visible light, because when we look through a telescope, that's what we would see. We would see the visible part of the spectrum. If we were to move to the infrared part of the spectrum, we can see infrared, but we need special cameras to be able to do that. And microwave and radio waves are also visible with special cameras. So we're not quite able to see them with the naked eye, but we can see them with special cameras, especially also goes for here in the ultraviolet, X-ray, and gamma ray part of the spectrum as well. So you'll notice that most of our telescopes that are in the short wavelength end of our spectrum are in space. And that's because the short wavelengths don't actually puncture through our atmosphere. Visible are both in space and on the ground. And for the most part, our radio part of the spectrum are ground-based telescopes, because it doesn't matter if you're looking through atmosphere or not for that. So I did mention the James Webb Space Telescope. The James Webb Space Telescope launched not too long ago and actually got to the part of our orbit out in the Lagrange point just past the moon. And it's set up. We've actually started to see images coming back from the James Webb Space Telescope. But this summer, we're expecting to see a lot more images coming through. And we'll probably have a very special Echo Live around the time that the James Webb Space Telescope starts bringing us back images. Scientists have been really excited because it was supposed to launch a very long time ago and has been sort of on hold for a little bit. So they kept running into some issues with it when they were making it. And so far, so good. It's gone through all of its checks. So we're very excited about that. Now, you can come to the Michigan Science Center and you can check out our telescopes, like I said, this Friday from 8 p.m. to 10 p.m. Or you can also do some telescope viewing at home. And you might wonder how. I don't have a telescope. Well, if you have a pair of binoculars, that's a really great way to take a look at some of the things that you can see up in the nighttime sky. Even if it's a pair of birding binoculars, taking a look at the moon or any of the planets is really fascinating. Now, if you want to look at things in deeper detail, that's when you need a telescope. But if you don't have one, that's okay. There's actually a program called Observing with NASA. And to get to this page, I just Googled NASA OWN and it came right on up. So with this, with NASA OWN, you can actually control a robotic telescope network, the Micro Observatory Robotic Telescope Network. You can send commands to that telescope, and when it is able to, it will take the image for you and send it to you. So it might take a couple of days because a lot of people do use this telescope, but it is going to take an image and send it back to you. So you're using technology at home to control these telescopes, which is very, very cool. So on the Observing with NASA site, you can actually pick the image that you want to take a look at. One of my favorite star clusters is called the Pleiades star cluster. And that one might be the next one that I try out. So when you click the Observe button, we used the example today of the moon. You can set the field of view, so you can set what type of lens you're using. You can set how long the telescope is looking at it, and you can also set up filters. So there's an RGB filter, so that's red, green, blue. This one has a gray filter to filter out some of the gray light, and be able to see a little bit more of the surface and like the craters and details of the moon. So this is a really cool option that if you don't have a telescope at home. But you can come down to the Michigan Science Center. We are celebrating on Friday our Scopes in the City event. And specifically, we're celebrating an event called the Statewide Astronomy Night. So if you live here in Michigan and you aren't able to make it down to the Michigan Science Center on Friday, I understand, we know that things like that happen. But if you want to participate in the Statewide Astronomy Night, you can check it out online, and there's lots of other sites. I know Kalamazoo is doing something for the Statewide Astronomy Night. Flint is doing something for the Statewide Astronomy Night. Bay City. So definitely check out in your area if you're here in the state of Michigan. Friday night, a lot of different observatories, planetariums, and science centers around the state are going to be doing some observing or other activities that evening. And that's through the MSU Science Festival, so the Michigan State University Science Festival. We do this every year, sometime in April. So if you're going to miss it this year, we'll probably be doing another activity next year. And the MSU Science Festival has lots of other amazing things that are happening, including some things here with the Michigan Science Center as well. So now you have your options of, you can look through a refracting telescope, a reflecting telescope. They can be big, they can be little, they can be remote and virtual, and they can be right here at the Michigan Science Center. So I want to thank you all so much for joining me here today for our Echo Live program. Echo Live is Wednesdays at 2:30 p.m. Eastern. So we can't wait to see you for the next one. Thank you so much and have a wonderful